Hi, it's power supply review time. Today we've got the Uni-T UDP6700 series, in particular the UDP6731, which is top of the range. They've got 4 different models. I'll put up an overlay graphic here. The 6720 is the lowest model. That's a 100 watt 60 volt jobby, all the way up to the 6731, which we've got here, which is a 360 volt, and this is an 80 volt jobby. So none of that 30 volt rubbish. These are higher voltage power supplies, which can be useful for, a whole bunch of applications. You might need 50 volts if you're doing like power over Ethernet or something like that. So a 60 volt or an 80 volt power supply, very useful, and they're in this vertical form factor, which I like. These are getting fairly popular these days. The good thing is that you can just stack them side by side. Yes, it's only a single output power supply. On the back we've got an IEC mains input, we've got the AC voltage selector, 220 or 110 for you Yanks, and it's got output voltage sensing as well. So 4 terminals. It's not on the front, but it is on the rear, and also you can get it looks like you can get the voltage out the back as well. Useful if you got it like maybe in a rack or something like that, or you're permanently powering gear. You don't want it coming off the front panel, you want it coming off the rear. And RS-232 as well. It's got some software, we'll try that out, and an earth grounding terminal and a fan. One of the problems with this form factor though is that you're very tempted to stack these up like side by side next to each other. Unfortunately, these are the ventilation holes here and here. So if you got them stacked right up against each other, that's going to be problematic. So kind of defeats the purpose of having that. So yeah, we're going to have to take a look at the internals. Speaking of which, you know what we say here on the EEVblog, don't turn it on, take it apart. And street prices in Yankee bucks range from $209 US up to $415 US for the model we're talking about here. But prices do vary. Like if you buy it directly on AliExpress, for example, you can get specials and things like that. I've seen it as low as like $150 or something like that for the lowest model. But this higher end model, yeah, you're paying for the extra power. A 360 watt power supply, wow, pretty beefy. So these vent holes here, these are actually inlets on either side, and because the fan actually blows out the back, so it's sucking air in. And if you've got it right up next to the other power supply, it's sucking hot air in from the power supply next to it. And unfortunately, like I've shorted this thing out, I have actually used it, and the fan barely turns on at all. But I haven't fully stress tested it yet, so we'll have a go. Alright, it's got a lot of screws on it, but just on the sides, and, pulls off. Ooh, that looks neat and tidy, doesn't it? Whoa, I'm kind of impressed by that right off the bat. And of course, when you've got a 360 watt power supply, this is a switching jobby. None of that linear rubbish. Anyway, that looks really neat and tidy. We've got a giant main board in the back, and if we swing that, there you go, double-sided load. That looks really nice, doesn't it? I'm quite happy with that. I'll take some high-res photos. I'll put them on the EEVblog website. Yeah, looks like we've got the current shunt resistors over here. Anyway, we can go through that later. But anyway, all the wiring's neat and tidy. It's all cable tied here. Earth wire's just soldered on there. I'm not sure what's going on there. Anyway, look, they do have a giant choke. They've got that's solid core wire. They've got a giant, why have they used a solid core wire for the earth terminal here, but that's gone through a giant choke. They've really done well with heat shrinking that, and it's going up to the screw which goes directly into there, and that's got a nice crimp lug on it. So yeah, no worries whatsoever. We've got our Y-class caps there going down to mains earth, so no problems there. But I'm just like, why have they used a solid core wire for that earth? I don't know. Got any clue? Leave it in the comments. Anyway, let's follow the money. We've got our mains input here. They're sleeved, no problems whatsoever. Goes down to, yes, our big clunking mains power switch down there on its own dedicated board. That's really nice. They didn't have to implement it like that, but I'm actually quite impressed. And they've put an insulating sheet under that too. Nice attention to detail. I'm liking it. So all of our switching elements are obviously on this heatsink under here. And here's our output caps here. Look at this giant output choke here. This is absolutely enormous. And oh yeah, there's a couple of more caps down there. So there's 4. So they're the output switching caps there by the looks of it. We've got 4 extra caps under there, but whoop, oh, whoa, hello. No, we've got an extra bonus output cap there on the front panel. So we've got a front panel PCB. Wow, there's quite a lot going on in here. There really is. It's quite substantial. Anyway, interestingly, our mains input here is over like on like the main board, but it's in its own complete isolated section like this. And you can see, so our mains input's going in here. I don't see it fused. That's interesting, but we've already got the fuse out there, but there's no onboard fuse. We've got all of our input common mode chokes, no problem. As I said, the Y-class caps going down to ground. X-class caps, if you didn't know, are the ones that go across the main, so active and neutral. So this would be an X-class capacitor, and Y, because it's shaped like a Y, and the bottom of the Y goes down to Earth. That's why they're called Y-class capacitors. So yeah, that looks all groovy. That is our bridge rectifier in there, on its own tiny little heatsink there for the bridge rectifier. Which brand caps have we got here? Yeah, I don't actually know what brand they are. So, okay, 105 degrees C rated, but yeah, okay, they're not exactly a Panasonic or a Nippon Chemicon, but okay. They are somewhat building this thing down to a price, but otherwise, I'm actually impressed by the design and construction. And this is our driver board here. They've got that on a vertical riser board. That's quite common in power supplies. You may want to change that later, and you may want to change the control later, and you don't want to respin your entire main board here. So yeah, that makes sense. And we've got an arm jobby down there, which I can't read on the LCD. That looks like an ST thing. And the other cap down in there is an LH Nova brand cap. They're the output caps. Yeah, once again, I don't know them. And this is actually specifically the UDP6731 power supply. You can see that down there. So yeah, it looks like they're spinning a different board for each version. And check it out, I totally missed that there's another fan in here. Wow, is that like... Oh no, it doesn't look like an afterthought because it's actually got a soldered, hard to see, but a soldered metal clip, like bracket down in there, that's holding that in place on the main board. So they obviously, maybe they decided that they need some extra airflow going over the main switching transformer here. Yeah, that's interesting. I can't say I've seen that before. So, it's something to note. But yeah, just the little extra air circulation inside there. Maybe that was like a dead pocket or something, but I don't know, have a look at the fan here. But I was actually wrong about these being the switching elements. There's actually 4 diodes under there. I'll put up the data sheet for them. They're like a Galaxy semiconductor thing or something. The main switching trannies must be under here like this. I'll see if I can get a number. And of course, they have got, you'll notice that's very, very close to the fan, so they're really sucking out the air through those power transistors there, and they've got the fins in the right direction to get the airflow through there. But yeah, this might have just been a little dead space inside, like from a thermal airflow point of view, and they decided, no, we need a fan in there. But that is attention to detail at the design stage, because, you know, they've got the bracket, they've actually designed that bracket, and they've put that on the layout of the PCB. And so it's not like they haven't just whacked that in as an afterthought, as a bodge. That's all part of the thermal design of this thing. Interesting. The other way to design this would have just been to have one large heatsink just going all the way along there and have your diodes and your power transistors on there. But obviously the designer thought, no, bugger it, I want the power transistors on my own little, heatsink down here, or two separate heat sinks down in here. Why they didn't manufacture that as one, I don't know. Maybe because it's these are maybe just off the shelf, jobbies or something. So yeah, they just used two of those and put them back to back, and Bob's your uncle. Not going to go through the designers this thing. Suffice it to say that I'm relatively impressed by the design and build quality of this thing. It looks like you're certainly getting your money's worth. And I'm not sure if you can see it, but right down in there you can see that there's a thermistor on the diode heatsink here. So yeah, they're putting in the requisite over temperature protections. And the switching transistors down in there, I can't quite make out the part, but I do see an ST logo. So yeah, potentially genuine ST jobbies. Mention the current shunt resistors, there you go, 5 10 milliohms in parallel there. They're the output ones. And down there on the output terminals, directly on the board, you've got reverse diode protection there. It's a little bit wimpy, not exactly a big power jobby. We've just got a low value cap there, and this cap on the output should just be in parallel with these ones, but it's literally right on the output. So it's got a significant amount of output capacitance, which does matter if you're switching into constant current mode, of course, because then your capacitors can still deliver that charge before the loop has time to respond. So ideally you want the, in power supply design, you want the lowest possible output capacitance while still keeping your ripple low, but also when you switch into constant current mode, you don't want to fry your circuit. So it's a trade-off. Now, of course, you might remember this Riden RD6006 DC power supply. This is also a 360 watt power supply in quote marks, and it's way cheaper than this Uni-T, but have a look inside, right? So both 360 watt capable. I believe this is, I think this is 60 volts max as well, whereas this is 80. But basically, we're looking at the power capability. I've installed this commercial Meanwell mains power supply here. So yeah, if you ignore all the main switching power supply up here and just look at this lower half, I mean, look at the difference here, right? Both 360 watt power supplies. You've got this massive heatsink here just for the switching diodes. You've got these rather large heatsinks here for the switching power transistors. And this one over here, just this piddly little fan like that with that piddly little heatsink and the output choke and the output capacitance, and just compare those to what you get over here for the same 360 watt rating. So if you just compare the physical sizes like that, you know this one is going to be lower noise. It's going to run thermally a lot lower temperature and than this thing over here. But this is way cheaper, so you get what you pay for. So from a thermal airflow point of view, really the only part of the grill that matters is the one on this side. The one on the other side doesn't really matter at all because, yeah, okay, you might get some inflow here and then down around the bottom side of the board, but there's no power stuff on the back really that you have to worry about. So, yeah, just don't block the vent on this side. You can probably block the one on the other side, no worries. Okay, let's power it up. Doesn't look that great on your 16:9 widescreen here, but here we go. We're on Uni-T, boot, Bob's your uncle, we're in like Flynn, and I like the display. And for you film aficionados, whoa, jeez, it's stuck. Unbelievable. Look at that, Bobby Dazzler. And you might think that the display's not very bright. It's the yellow display here because we haven't actually set the output on. So I can switch the output on and it gets brighter and then it actually displays the output. So when it's actually switched off, it goes dimmer like that, just to indicate that, you know, it's off. But nice bright output thing here, and with constant voltage and constant current mode indicator, turns red in constant current mode to match the silk screen. Everything's hunky-dory. Standard terminal dimensions, no worries, look at that, Bob's your uncle. So obviously they've got the 4mm banana jack and the binding post there, don't mind it at all. We've got the hole in there to put our wire straight through, and also some back part. I would have liked to have seen the back terminal, like the back metal, a little bit bigger for putting your wire in there, but overall, I don't mind those. They're pretty decent binding posts. I'm pretty happy with the layout, actually. We've only got the one knob, of course, share between the voltage and the current. We'll see that in a minute. Got some arrow keys to select which digit you actually want. We've got an escape key for the menu. We've got an enter key for entering in menus. Doesn't do anything in normal mode. And as I said, we've got the nice output button there. No worries. We've got a menu button. We've got voltage and current right next to the knob. No problems. Over voltage protection and over current protection. If you actually hold those down, you can get in there. And we've got 3 voltage and current memory presets like this. And we've got our lock button right on the front panel. Really good, so that once you hit that, it's not very bright. I'd like to see it bright like that. But it shows a little key lock indicator on here. And it doesn't matter what we do now. The keyboard is locked. We can't do a damn thing unless we unlock that. Brilliant, because you don't want to blow up your $1 million widget when you know management's going to come around and they're going to play with your $1 million prototype and they're just going to go, oh, what does this knob do? And you've got it hooked up directly to your 5-volt rail and you blow your entire board on your $1 million project. Yeah, trust me, I've seen it happen. You don't want that. Lock. Beauty. And it does remember your last set voltage and current. So we can go in here, voltage, let's say we've got, 5.16, and then we've got, 0.44 amps, something like that, okay? And we switch that out. And if we just switch that off, boom, we go back in there, and that should come back. And it does. Winner, winner, chicken dinner. And as for the display, I really like it. The digit's quite big enough. You can read them from some distance away. It could have been a little bit bigger. But anyway, you've got your output voltage, you've got your output current, and it calculates your output power. Nice 10 millivolts resolution on voltage, 1 milliamp resolution on your current, and 10 milliwatt resolution on your power there. And you can see it's pretty fast at updating. No worries. And over here, you've always got your set voltage, current, and output power, although I don't think you can set an output power limit. The constant current limit indicator there is not that bright. It's a bit hard to see, but you've got it nicely down here in the red. No worries. And your limits here are your over voltage protection and over current protection. I think they're just software. There's not like has a hardware crowbar, I don't believe. But anyway, we can set that and our little cursor comes up and then we can adjust that, so we can move our cursor over using the cursor keys, and this is how you set the voltage and the current. So let's say we're powering a 5-volt digital board. You absolutely do not want your voltage output going above 5.25 volts like that. So we can enter 5.25, and one of the cool things is you can either use the arrow keys like this, or you can just press the knob like this to actually switch your digits. But anyway, once you've done that, you just hold that in, or you can hold in the enter key, and we've turned on our over voltage limit like this. So then if we go into voltage like this, 4.5 volts, we should not be able to go above over the limit voltage, 5.24. So no idiot manager can come around and screw up your design. I wish it could be password protected. And another nice feature, you can set it so that the output can automatically come on when you repower the thing. So that's what keep up the top is, and you can actually access that down in the menu there, output state. So I've set that to keep, and if we shut down this and we repower, we should find that it should come back up and the output will switch back on. Beautiful. And you saw it there before, the knob will actually act as a proper power supply knob. So if we go into voltage set mode, our cursor's on the last digit over there, and you can see that our voltage will actually change instantaneously on the output like that. And if we jump over to 1 volt like that, it jumps down pretty quick. So that output capacitance ain't doing a lot there. So yeah, that's changing really quick. Nice. So it acts like, a proper old school knob on a power supply rather than, you set the voltage and then you go. But some people prefer that. Maybe it should have been selectable. I don't know. Leave it in the comments down below, but I like that it actually does that. But I can understand people who want it to, they don't want to ramp it up. They want it to suddenly set the voltage and then jump up. But you can do that same feature with the memory buttons. So you can just program the memory buttons and then just hit that and it'll automatically jump up to whatever voltage you currently set. So I guess you do get the best of both worlds. And speaking of the memory groups, if you want to program them easy, we're currently set to 4 volts and 0.44 amps, and we can just hold down 1 like that, save OK, and then we can just go to whatever this one is switched to. I don't set to 0. Yeah, they're both set to 0. Haven't used them yet, but now we can jump back to 4 and 0.44 amps. Nice and intuitive, works perfectly. But they advertise the fact that they actually have 200 groups of these 3 memory spaces. So if we go in here, we can actually go into memory here and see M1, and it shows the actual displays, but we can actually increment that, and we can have like 200 times 3. Like, that's just nuts. Who decided that like 300? No, sorry, 200. I said 300. 200. Oh, only 200 times 3. Only 600 different power supply settings. Oh. There doesn't, however, seem to be any ability to disable the 4-terminal measurement on the output. So if I disconnect the 4-terminal measurement on the back, it should not read anything here, but I've disconnected the positive one, and it's still reading. Let me disconnect the negative. There you go. I've disconnected both of them, and what do we get? Bueller. We still get our 4 volts. What? It shouldn't read anything. So the only explanation for that is that they've got loose high impedance coupling internally in there, and so if you apply so if you disconnect it, it works perfectly, although they do supply these shorting links with it, so yeah, it doesn't make sense. And then if it's high impedance, then you can override it. But anyway, let's measure the that we're actually getting the output voltage on these terminals, and sure enough, there's our 5 volts. And if we go to our sense lines, we should also be measuring, 5 volts. So let's try and override those sense lines with another voltage, and then our display should change. So first thing we do is we'll short out our sense terminals, and bingo, oh, error, disable output. What? It's disabled the output because the sense is 0? Okay. Yeah, it's literally switched off. Okay, safety feature. Great. But no, it should have gone into constant current mode though, right? Something's up there. Look, it looks like I've permanently done something to it. I just repowered it. I thought I was shooting the video, I wasn't. Yeah, I like error, disable output. There's nothing on the output. I've got my inputs floating. And have I done something to it? What have I done just by shorting out the sense terminals? Maybe I shouldn't have done that, but I should have tolerated that. Okay, I've actually fed the outputs back up the clacker again. So basically the shorting links, have we recovered? We have recovered. There you go. So it didn't like that. Even repowering the thing didn't fix that, but we're back. Okay, interesting. Maybe there's a cap on those pins it didn't like. I don't know. But sure enough, if I connect up a battery, it measures the battery voltage. So that's exactly what you'd expect. But if I try and turn the output on, so I'll hit the output button here, and error, disable output. So I guess that's 2 greater voltage difference, and it's disabled the output. Maybe it knows that there's no load there, so why should there be a voltage differential there? It kind of, maybe it's sort of being too smart for its own good there. Yeah, I don't know. I'd have to do extensive testing to try and figure this out. But yeah, anyway, voltage sense works. Now, the accuracy spec on this thing is actually rather good. I'll put up the specs here, and the output accuracy is 0.1% on voltage there, and I've got it hooked up to my BK Precision 8601, which is a 0.02% class accurate instrument, and you can see 4.4417, 4.45 there, so it's not too shabby. Set it to precisely 10 there. We're 9.98, so we're 2 least significant digits out. I do believe that's in spec. You can get your confuser out and check. Actually, according to my BM786 here, that's pretty much bang on. So, yeah, I don't think there's an issue there. Oh, what's up with my 8601? I'm getting no loss on the leads because we've got no load yet. Put a 1 amp constant current load on here and we're getting 1.008, so I think that's within spec. And according to my 786 over here, we're 0.99, almost 999 there. So it's reading a little bit over there on the current, but that's neither here nor there. As I said, I think that's within spec. Now you'll notice that I do actually have my sense leads connected across the load here. And look what happens if I actually disconnect the load. Then bingo, error, disable output. It's going to do that disable thing again. It didn't like that. Something sparked. And I put it back on, and of course it's reading exactly 10. Even though there is a drop in this leads, it's actually compensating that and reading back 10 exactly on the output. So it's actually outputting. So if we actually measure down here with this meter, oh, it didn't disconnect. It wasn't fast enough. There you go. That's interesting. We should find that this voltage is higher than the actual 10 volts there by the drop in the leads. And 10.05, because we're only an amp, but there is 50 millivolt drop across those leads. And if we increase the current, that'll be higher. So I've increased that to 10 amps there, and now we're delivering, it says bang on 10 amps, and so there's a bit of non-linearity there. But anyway, so we should have a bigger drop on the output here, because, yeah, 10.4, so we got 430 millivolts drop across those leads, but because we're using the external sense, it's going to read precise, it's going to deliver precisely 10 volts across our load while compensating for our leads, and that's great. But the problem is that you can't disable that. I think that's a bit of an oversight. You should be able to disable the external sensing, I think. That's just, yeah, because you don't want it, doing playing silly buggers, disabling your output, and because I've got to go in there. If I want to change it, I've got to go physically in there and actually short out the outputs on the back of this thing again, and I don't want to be doing that. Higgledy-piggledy. Anyway, even at 100 watts output, that fan has not increased at all. I can't hear it. It's basically silent. So, yeah, that's a winner. At 100 watts, I guess we'll have to stress it at the full 360 and see what happens. And at 200 watts, I still can't hear a thing. And there's barely any airflow coming from that. In fact, I might be hearing the fan from this one instead of this one. I can barely hear it. Like, it's just not switching on. So that's great. And we're now up to the full 250 watt capability of this electronic load, and it just switched on its fan. So I don't know if you can hear that fan noise, but it's not coming from here. This basically hasn't increased at all. Beautiful. What I've got now is I've got it on constant resistance mode set to 1 ohm. Now this has killed power supplies in the past because this is going to have a loop response in the electronic load here trying to keep the 1 amp there. And it just goes into that current limit just fine and dandy. So nothing's oscillating, nothing's dying. It's just hunky-dory. So it's a simple test, but it just does show that that loop response in the load isn't upsetting the constant current mode in the power supply. And even if I set the maximum output voltage of 80 volts here, it's still handling that just fine. So I can disconnect that, error disable output. Whoa, sparky. And, well, yep, no problems whatsoever. Okay, maximum power draw, 365 watts. In fact, I haven't actually turned it up. Well, yep, something just happened there. The output's still on. Oh, constant current, it went into constant current mode. What happened there? I'm not quite sure. I have to review the footage. But, yeah, anyway, let's try that again, shall we? Nope. Where output is 0.16. May I didn't have my load switch. No. Hang on. No, 13. What's going on? Something's happened. Let me stop. I'll get back to you. Off. And off. Okay, I've looped the sense lines on the back. I've powered it off. Let's power it back on and see. Hopefully, I haven't buggered it. No, 18 volts. It's back. Okay, let's try that again. Okay, what I've got is an overcurrent protection input disabled here on my Rigol load. But watch what happens. Like, both of these loads are off. Okay? Like, they're both, the output is switched off. Okay, so they should be a high impedance input. Now, watch what happens when I connect over here, right? It's just volt, I've got 18 volts, 13.5 amps set. It's oscillating. And I can hear some sort of oscillation thing happening. You can see it on the LED there. The LED is blinking. And this is going silly buggers. What? Disable this? What? My Rigol load is causing that? The input should be disabled. But why would this be going into constant current mode if our current limit is 13.1 amps? It doesn't make any sense whatsoever. Let's plug this back in. Yeah? It's causing that issue again. Oh, I just realized that my terminals here were loose because I had my wires in there and I didn't screw them back up, but that shouldn't do anything because this load is off. Just plugging in this load with overcurrent protection disabled is causing this thing to oscillate with a 13.5 amp setting. What's going on? Okay, let's see what happens, right? I've just got 18 volts and I've just got like 13.5 amps set there. What happens if I short these out? Let's try it. Yeah? 13.5 amps? No worries? Wow. What the heck is this load doing? Okay, even if we postulate that there's something weird happening with this load, even though its input is supposed to be disabled, it doesn't explain why it would cause this supply to like oscillate in and out of current mode when it's set to 13.5 amps. That just doesn't make sense. What the heck is going on here? Maybe you're screaming at me, but I'm not seeing it at the moment. What would actually cause that? And this seems to work just fine and dandy. So I'm going to plug this back into the load over here. Yeah, got it around the right way. And we've got our 18 volts. And let's just go constant current mode, 7 amps. 7 amps. Everything's working fine, so we haven't blown anything. But what the heck's going on with this thing? And causing, but even if this thing is somehow faulty and doing something weird, it doesn't explain why this would go into current mode. I'm going to like just measure ohms on the input here. Like, what the heck? Yeah, that's shorted. Wow. Okay, so we might have killed the Rigol DL3021. That input is shorted. Overcurrent protection input disabled. We might have killed it, put in both of these loads independently in parallel across here. What? Why? Okay, I'm going to choose okay. Going to repower this. I know that like now we're getting into the territory of troubleshooting what's going on here. But we may have killed it. Oh my goodness. Okay, let's show. No, it's not shorted anymore, all right? It's 200K. Okay, so everything's hunky-dory now. All right, so that's gone into some weird mode. Okay, so let's go over here, and we had that set for, let's set that for 7 amps. I think we had that before. No, 40 amp range, 7 amp current limit, and let's go over there and see if it works. Got to turn it on. And it works. We haven't killed it. Okay, that's weird. Okay, this Rigol, we'll rack that up to this Rigol load doing something weird, and it was shorting out, and maybe it was it's obviously not a dead short, it was some sort of electronic short, and it was causing this to oscillate. But anyway, okay, that's kind of a great test. This thing was oscillating off and on, off and on. You saw that at like 13.5 amps at 18 volts. So that's at a couple hundred watts, and that was like not, this thing didn't flinch at all. Well, we haven't killed it, so I deem that to be a great test, an inadvertent test, but that was kind of sort of what I was trying to do with that 1 ohm constant resistance mode, trying to get it to, you know, loop or oscillate or do something weird like that, and we actually got it to do it. So, okay, that is a pass. Great, it's robust. Okay, ripple and noise here at low load. The value, the spec is 12 millivolts RMS. They don't give you a peak-to-peak value, but as you can see, well, I can clear those sweeps and reset the averages here. Peak-to-peak is 137 millivolts. This is at a 5-volt output voltage. RMS 5 millivolts. So yeah, no worries. So it is under the RMS. You can see the clear switching noise here. This is 50 millivolts per division, 120 kilohertz switching frequency there, and well, yeah, that's what you expect from a switching supply. You get what you get, and you don't get upset. But it's well within spec, RMS-wise, and if we bump the voltage up, we'll find that that is going to drop. Let's go all the way with LBJ, shall we? 82 volts here. And it's slowly coming down. We're AC coupling, of course, and it's actually much less there. So at the max voltage, you can see that the peak-to-peak has gone down significantly here. But, you know, we're only talking, 78 millivolts peak-to-peak. But the RMS has gone up a little bit. We're talking 6 millivolts there. But, yeah, still half of what the spec says. But let's whack a load on this thing. So if you're keen to see the switching noise in there, there you go. We can stop that, and there you go. There's our switching, and if we go out, you can see, whoa, there's not really much ripply there, is it? There's really no low-frequency ripple there, because all you care about is really, on the switching supply, is the switching frequency, which is 120 odd kilohertz. I'm going to plug in a 2 ohm resistive load here, so at whoa, 20 volts, there you go. We're delivering 200 watts. Oh, look at that. We're all over the shop there. Look at that. We've got an extra little doodad in there, extra little frequency switching. So that's still at 120 kilohertz there, but it's added an extra. That's just not a capture artifact. That's actually really there. It's actually got 2 little switches in there, so it's changed modes at that higher current. And what happens if we go into constant current mode there? So I'll do just 9 amps there, and well, let's restart that. Well, there we go. So, whoop, there it is there, and let's plug it in. Constant current mode. Yeah, it's doing the same. It's doing the same job there. But you'll see that we have some lower frequency stuff in there now. Look at that. There you go. It's getting toasty now. Whoa, Ernie Bernie. But we're still looking at 7.5 millivolts RMS there. And let's test the switch on now. And yeah, I had it set to AC couple and went, yeah, DC couple. Dave, you dork. So let's try that again. Let's single shot capture. We'll switch our output off. 1 volt per division. Rising edge trigger. Smack in the middle. And boom, there we go. That's very nice and clean. There's only a small hint of something happening right at the start here, but you know, that's a nothing burger. So yeah, I'm pretty happy with that. There's no overshoot at all. Beautiful. And what time did that take? It's 200 milliseconds per division there, you know, about 300 odd milliseconds, something like that, to ramp on. But it's not, but what you care about is nice and clean. There's no overshoot, so it's not going to ruin your day if you're, you know, you're powering your 5-volt TTL stuff and it jumps up to 12 volts. You don't want that. And there's the same time base at 80, the maximum 82 volts there, and you can see that took, what's that, 800 milliseconds or something to ramp up. But once again, there's no overshoot at all. It's beautiful. Okay, let's try that again, but let's do falling edge, shall we? So single shot capture, and yoey, that's taken a while. I have to zoom out. Let's try that again. Once again, from maximum 82 volts. So we'll switch it on and switch it off. And come on. You can do it. Boom. Look at that. Perfect ramp down. No worries whatsoever. And how long's that taking? A couple of seconds? Yeah, 2.2. But it's nice and clean. There's no overshoots or anything. And there we go. That's the ramp down from 5 volts. That was me ramping it on. And that was ramping off. So once again, that's very clean. Beautiful. Okay, let's test it going into constant current mode, shall we? So there we go, and boom. There we go. That went pretty cleanly into constant current mode. We don't know if, there's some contact bounce in there or not. Constant voltage mode down into constant current mode. Didn't overshoot, didn't oscillate, do anything weird like that. Let me just try that again, shall we? Here we go, and boom, like that. Yeah, it looks like that's just my contact. I'll see if I can do it faster. I'll go over here. Let's try it again. Boom, look at that. There we go, clean. Clean as a whistle. So what does it look like exiting constant current mode? Well, I'm glad you asked. We can go in here and we can go back on the trigger on the rising edge again, single shot capture, and boom. Ah, look at that. That's clean. We can try that again with the longer time base, but you can see it there. No worries. Yep, it's clean. Clean bill of health. Only one more test left. What happens when we power it off and we do the power on thing where it like automatically switches on? I wouldn't expect any difference, but I will check it nonetheless. So hopefully I've got that trigger right. And 5, yep. Beautiful. So no worries whatsoever. So it passes all the tests going into and out of constant current mode, and switching the output off and on, and even restarting the output when you switch the unit on, physically on at the power switch. So yeah, and at higher voltages too. So it's pretty good. I like it. Okay, lastly, let's try the instrument application which you can get with this thing. Sadly, it doesn't have networking, so it's got the RS-232s. So I've connected it in, I installed it, had the stupid National Instruments NI Visa install, and that didn't work because I've probably already got it installed for 10 million other things. Hate the bloody NI Visa thing. Leave it in the comments down below if you're similar. Anyway, I just did the scan. It was default, here we go, RS-232. It was default 9600. You can change that in the menu in there. So let's UDP6731. It found it, and there it is. And sure enough, 5 volts. So we can control this sucker. There we go. Look at this. We can turn it up with the knobby. Oh, that took a while to respond there, but yeah. So we can use the slider. Presumably we can type in 5. Yep, we can indeed. Okay, we can turn on over voltage protection. We can set the voltage there. Nice. Okay, so let's actually try that. And if we try to slide that higher, nope, it beeped at me. I heard it beep. So, yep, it doesn't show me a message, but it beeps and then goes back. Winner. And now we can do the listing thing. So we can actually set, whoop, hello, why is that? Well, let's go full screen on. Oh, here it is. Okay, right. So this is what this is the graph. That's really quite nice. Voltage and current here. So that's really groovy. I don't know where that little 0.15 amps came from. I've got nothing connected to it. Don't know what's going on there. Oh, so this is a log. I thought this was this is logging like every second. Or whatever, a bit more than a second. I thought this was like the listing, because you can set up a lister thing so you can get it to like cycle through different voltage and current modes and things like that. Good for like ramping up products and, you know, automated testing and stuff like that. So that's just a log. Okay, so that's just a graphical table of, and no, it is, yeah, it's like twice a second. Yeah, I think it's about twice a second there. What are our options? Interval, okay, sample time, interval, sample interval, sample points. So let's go to 100 milliseconds and see what that does. Doesn't seem to be any quicker. So that's like the maximum it can do over the RS-232, I guess. Now, as I mentioned, the manual here talks about this list and delay function, and it looks like that was like runs on the screen, but I didn't see that when I was operating it, so, and it doesn't seem to be in the software, so I used to assume it to be in the software, but it doesn't appear to be. It doesn't, there is no, like, well, no, that's just English, and like, there's no options to do anything. We can export the data, okay, but, it's kind of useful that we can log it, but yeah, and that's just a quick setting, so we can set voltage and current, but that's in addition to the memory down here. But anyway, it looks like you can set up those like 200 memories here, so you can set those up, but also this just allows you to quickly jump and do whatever. But that's a bit underwhelming, isn't it? I was hoping to get like a lister. Bummer. Well, that's embarrassing. How did I not find this before? While you're in regular operation, you can just use the arrow keys to go across to the delayer function or to the list function. So there you go. That's pretty cool. All right. It wasn't obvious. Shame you can't do it in the software, though. It doesn't look like you can. Now, the delayer function is useful, more useful if you had a multiple output power supply and you want to like sequence power supplies, say for like a complex FPGA or something like that, that needs, you know, sometimes to power up the voltage rails in a certain sequence. Otherwise, you can come a gutsy, you can get like SCR latch up inside the chip and stuff like that. Anyway, so yeah, something like that. So unfortunately, there's no external trigger on this thing, so it's not like you can have like a manual external trigger. So you could have multiple supplies and then you'd have to start the the delayers all at the same time, but you can potentially do that. And the list function, as I said, is just the ability to like cycle through different voltage settings, voltage and or current settings based on time, so you can sequence the voltage and current to do particular things that you want to do over a sequence of time. So if we go in there, we can cycle infinite, or we can go as many cycles as you want. So you can just do it once, or you can just keep on repeating. So let's just do it once, shall we? Unfortunately, the user interface is very confusing. They've got what looks like soft buttons down here. And of course, this is not a touchy-feely screen, and there's no actual buttons there. So instead of that, you've got to actually, escape from there, and then your knob actually selects the various things and status stop, and then you can enter that, and then run, save, and clean selection gets, I guess that resets it all, does it? It's totally non-obvious. So then we go in there, like we can go into that one, and then we can select which one we want like that, and then we should be able to, okay, let's go like first set in here, let's go So, you know, it's a bit tedious, but it works. Okay, one, and then we can escape like that, and then we can jump down to, let's just keep it on 2 amps, and let's just go over, so let's escape back out and go over here, and then we can, enter, yep, and we can go in there, and then we can adjust that to 2 volts, for example, and then we can escape out of there. Once you get the hang of it, it kind of works. Of course, this is not something that you set up all the time, so the fact that it, you know, takes a little bit to do it, it's neither here nor there. Right, so how many of these? We should go up to the full. Is that the 48 for the count up there? Yes, it is. Okay, so that's how many counts that we go through. So I've set up, I'll set up 5 here. It would have been nice if it like auto-scaled this window, because it knows I've only got 5 counts, and it knows that I'm only going 1, 2, 3, 4, 5 volts like this. So it'd be nice to be able to auto-scale that, because you can just kind of sort of see this. If you squint, you can see the steps I've actually programmed into there. Yellow is the voltage and blue is the current. Anyway, I'm going to run this and we'll see what happens. So okay, let's run that. So I've selected run. I've got 1 second for each of those. And, single shot capture. Okay, let's run. And we're single shot capture on the scope. Hopefully I've got that set up correctly. And it's running and it's completed in 5 seconds. What's my scope doing? Yep. Oh, there it is. Oh, that's interesting. Is it not? What's going on here? Look at this little extra sort of like down and up. What's going on there? It's in each one of them. That is weird. Is it not? That there's something going on there. Not too happy with that. That should be clean. We've seen before that when it changes voltages, it does it really cleanly. So, not sure what the deal is. Just as a quick sanity check, I've got 5 volts programmed into M2 here and 6 volts programmed into M1. So I'm going to single shot capture that, and we're at 5 volts, and I'm just going to go to 6 volts like that, and I'm going to see what happens. Oh, I had the threshold set wrong. dumbass. All right, let's try that again. I've got a faster time base this time. And we're going from 5 to... Oh, it wasn't bloody in the center. Unbelievable. Single shot capture that again. It's in the center. And 5 to 6 volts. Boom. It's clean. Right? It's clean. So what's going on? That's the same 1 volt step. So what's going on with that programming mode? That is really weird. Let's try that again and see what happens. Run. Boom. It's running, running, running. Should capture it. And boom, we get the same little quirky thing. That is some sort of bug. I'm not sure what the heck that is, but yeah, gotcha. Uni-T, get back to us on that one. Firmware update. Leave in the comments down below if you've got any good idea what would actually cause that. Offhand, I don't know. So anyway, that's a review of the Uni-T UDP6700 series, the top of the range 6731. As I said, available in like different voltage and current and power grades here. But yeah, a very nice supply. The design and build quality is really excellent. I like it. I do like, you know, the list is a bit, it's a bit how you're doing in its user interface, but I do actually like the main user interface is really quite nice and it works quite well. It seems very robust, and it hasn't got the best peak-to-peak noise, so if you're, you know, after that peak-to-peak noise, it's decent RMS noise, but yeah, the peak-to-peak's a bit high, but anyway, that's why they don't spec it, right? Yeah, I expected it to be a bit better, but anyway, it looks like a really well-built and robust supply in the nice form factor. I like these small vertical form factors, and the UI works really quite well. So just an issue with that. I don't know what's going on over there. They probably need to fix that. And yeah, the software's a bit disappointing. I would have liked to have seen better. And I checked at the moment there is no support for this in the test controller, that free test controller software, which I've done a video on. But hey, you can easily add it yourself, or I'm sure you know, someone will actually add that sooner or later. But yeah, it's a nice little power supply. It's worth checking out. So anyway, I'll leave the link down below. Thanks, Uni-T, for sending that one in. As always, thoughts and comments down below or over on the EEVblog forum. Always linked down below. Some teardown photos over on the EEVblog website, and my merch as well over on EEVblog.store. Catch you next time.